example 2. In example 2, we're going to determine the equation of the lines that are tangent and normal to the graph of f of x equals tan of x divided by x at x equals 2. So let's keep in mind what we're trying to solve. So what we are trying to find is y minus y1 is equal to m times x minus x1. So we're going to need a y1 value, an x1 value, and slope. Well, we have our x1 value because it's at x equals 2. So for step 1, we're going to determine f of 2, which represents our y2 value, and store. So again, f of 2 is going to be our y1 value. So in order to do this on the calculator, you do f of 2 is equal to tangent of 2 divided by 2. And you're going to get a number. So let me bring up the calculator now and show you how to actually store it. So we go tangent of 2 divided by 2, and I get negative 1.0925. And to store that, you push this button right here called store, and then it's going to store it on whatever letter you like. So I'm going to choose it to be K. So to get K, I push alpha, and then find the letter K. And again, the letter I picked does not matter. But now if I type in alpha K, it'll spit out that negative 1.0925 again. Step 2. So we need to determine the slope of the tangent line, which is m is equal to f prime of 2, then store it. So again, the slope is the derivative at 2. And so on a calculator, we can just do that without having to do any real work. So we get d dx, parenthesis, tangent of x, all divided by x, at x equals 2. This whole piece is equivalent to f prime of 2. And in the calculator, I'm going to store this as y1. So in the calculator, I go to y1, and I type in tangent of x divided by x and push enter. And then I exit back out. And to get the nth derivative, we do a little shortcuts, which is alpha f2. And 3, we get the nth derivative. So we get d dx. And from here, I can do y1. Or you can just type in your original function here at x equals 2. That's going to give me 3.433. So then I'm going to store that as m for slope. And then now what we need to do is write the equation of our tangent line. So the equation is y minus y1 is equal to m x minus x1. Now recall, we let y1 equal k and m is equal to m. So I get y minus k is equal to m x minus 2. And now what we're going to do is just solve that for y. So I get y minus k is equal to mx minus 2m. And y is equal to mx minus 2m plus k. Now I know this might look very confusing, but at this point, we can just actually plug this whole thing into the calculator. So now what I want to do is plug the negative 2m plus k into our calculator to get our number. So I get negative 2m plus k. And that's going to give me negative 7.959. So I get y is equal to 3.433 x minus 7.959. And so this is the equation of my tangent line. So for the normal line, I get y minus y1 is equal to negative 1 over m x minus 2, because this is how you find the slope of the normal. So now we're just going to do a little bit of rearranging using algebra. And I get y minus k is equal to negative 1 over m x minus 2. Y minus k is equal to negative 1 over m x plus 2 over m. So y is equal to 1 over m x plus 2 over m plus k. And this part I can put right into the calculator. So I get that negative 1 divided by m is going to be equal to negative 0.29124. And I get that 2 divided by m plus k is negative 0.5100. So I get y is equal to negative 0.291 x minus 0.51. And this is the equation of my normal. So now on your own, I want you to use this method to determine the equation of the tangent and normal lines to the function x squared cosine x at x equals 3. Alright, so the first thing I want to do is write down what I'm trying to get. So my goal is to get y minus y1 is equal to mx minus x1. So the first thing we need to do is go back to our calculator and put some stuff in there. Keep in mind I'm going to let y1 equal k, which is equal to f of 3. And m is going to be equal to f prime of 3. So I go into here. I'm going to turn off this function and type in x squared times cosine of x. And that's going to be my y2. And then what I need to do is determine f of 2. So I can actually do y2 of 3. And I get negative 8.9. And so I'm going to store this as k. And so now I'm going to set this up the same way as before, where in order to find the derivative, I'm going to do alpha f2 nth derivative d dx, and then type in y2 at x equals 3. And that's going to be my slope. So I go back over here and I'm going to write y minus k is equal to m x minus 3. So I get y minus k is equal to mx minus 3m. So y is equal to mx minus 3m plus k. This part I have to put into my calculator. So what I need to do now is store this as m, so I can override my previous slope. So I store this as m. And then now I need to multiply the negative 3. So negative 3m plus k. And I get 12.72. So I have y is equal to m, which is negative 0.721, x plus 12.72. And this is my tangent. And now to find the normal, I do y minus k is equal to negative 1 over m x minus x1. So y minus k is equal to negative 1 over m x minus 3. Y minus k is equal to negative 1 over m x plus 3 over m. So y is equal to negative 1 over m x plus 3 over m plus k. So on the calculator, negative 1 divided by m, I get 0.13869. And then I need to do 3 divided by m plus k. And I get negative 9.326. So y is equal to 0.138 x minus 9.326. And this is the equation of my normal.